last meeting we started with footing, and I talked about type of foundations, shallow and deep foundations, and what are the different types of footing: isolated, combined, strap, and we have something called mat or raft foundation. And the deep foundation, the most common type is piles. And I talked also about something called bearing capacity. Bearing capacity is the strength of the soil. Bearing capacity is the strength of soil. We have soil, sometimes it's rock, very strong, sand, strong, gravel, strong also, clay, weak, a little bit. So we need to figure out the capacity of soil for foundation. Last time I started with strip footing. Strip means we have something very long, like this shear wall. It's very long. So the foundation for this wall will be strip footing. But for the common column, it will be isolated footing. We have few steps. You need only to follow these steps. The first one, I need to add dead load plus live load reactions without any factors. Then I need another combination with factors. So this one is unfactored total reaction. This one called factored total reactions. Guys, by the end of this semester, I will give you a project exactly the same like you are doing in capstone project. We will finish it in 1 week. Don't worry. This project will be done with software. The software will give you what is the reaction of dead load alone, what is the reaction of live load alone. During our semester, in the problem give you the dead load, the live load. So you can do combination. I will give you how, or I will show you how the software can tell you what is the dead load value and what is the live load value. Also, the software can do combination with these factors, 1.2 and 1.6. Anyway, third step, we need to calculate the Q net. Q allowable is given by the geotechnical engineer. But sometimes, it's not all the time. Sometimes we need to make excavation in the ground surface to put the foundation, the footing, and then construct the wall, and then we are applying fill soil, filling this excavation. So at this location, we have 3 loads, 3 weights. The first one, weight from the footing itself. The second one, load from the soil above the footing. The third one, the reaction or the load coming from the wall, which is P. Dead load plus live load. So the final pressure on the soil pressure, will be Q net. This Q net equal Q allowable, which is given by the geotechnical engineer without any load, minus weight of concrete, or to be more clear, weight of footing, minus also weight of soil. So if you did QNet, you canceled the weight of footing, you canceled the weight of soil. We still have only the weight, the load coming from the wall or from the column. So this step, I'm gonna calculate QNet equal Q allowable, which is given by the geotechnical engineer, minus gamma SHS, gamma S for soil, HS, the height of soil above the footing, minus gamma concrete H footing. This footing has a thickness, HF. The fourth step, I can get the area of the footing by this expression. Area of footing equal B divide QNet. QNet from this step, P dead load plus live load without factors. And we stopped last time at this point. Guys, for the concrete, for the footing thickness, I'm gonna assume it. I will determine the footing depth by trial and error. What you mean by trial and error? The designer will assume, and we will do check on our assumption. Probably your assumption will be correct, probably your thickness will be enough, and probably it will not be enough. So the determination of footing depth is a trial and error. So I'm gonna assume the depth or the overall thickness first, HF, something around 16, 18, 20, 22, 24, in this range. Multiples of 2, 4, 6, 8, 10. But I highly recommend to start from 16. Don't go below this number. Probably it will not be, it will be unsafe. So if you are good, I am gonna start with HF equal 20. HF is the total thickness. And you know, we have something called depth for steel reinforcement. I'm gonna assume we have 4-inch concrete cover. Anybody can tell me why the cover in footing is too much? Do you remember the cover in beam? Do you remember if you have a beam, this covers something around 2 or 2.5? For column, if you have a column and you have reinforcement, this cover around 2.5. Can you tell me why, if you have a footing and you have a steel reinforcement, why this cover is 4-inch? It's too much. Do you know why? Do you know why? The cover of concrete to the steel reinforcement is too high in case of footing. Thank you, Oliver. Good answer. Yes, this is the biggest issue in foundation. This concrete has a direct contact with soil, and this soil has sometimes groundwater, sometimes has salt, sometimes has sulfate. So we can expect attack to the reinforcement. We can expect corrosion. So to protect steel reinforcement, we need to increase this cover thickness. So ACI recommend around 4-inch concrete cover. Okay. That makes sense. The following step, we need to get the ultimate pressure under the footing. Ultimate pressure means I'm gonna use the factored load, which is 1.2 dead plus 1.6 live. So guys, we have two steps right now. The first one, if you are looking for area of footing, we are going to use the unfactored load, which is dead plus live without factor. If you are looking for ultimate soil pressure, ultimate means your load must be factored. So 1.2 is dead plus 1.6 live divided by area of footing. I can figure out the ultimate soil pressure. We have issue with shear. We have shear in footing, yes. And this shear, the critical section for shear at distance D from the face of the wall. So this area under the effect of Q ultimate will make failure in shear at this location. Can you get the shear force V ultimate? One more time to make it clear. Guys, at distance D from the face of the wall, I have critical section here for shear. I can expect failure of shear in this footing. Under the footing, we have Q ultimate, which called ultimate soil pressure. This ultimate pressure will make shear force. How can I get this shear force? Okay, go ahead and multiply this pressure by this remaining area of the footing after the critical section. If you multiply Q ultimate by area for shear, this one, I can figure out V ultimate, which is ultimate shear force. Remember, it's a good question in the PE exam. Where is the critical section for shear in footing? At distance D from the face of the wall. So at this location, I will draw a line. The remaining area of footing time Q ultimate is the ultimate shear force. This ultimate shear force, by this expression, will give you a depth. You need to make a comparison between this depth and your assumed depth. If you assumed a depth greater than this value, you are okay. If not, your assumption at this point is not good. You have to increase what you assumed and keep going to repeat Q ultimate, V ultimate to make sure the calculated depth is okay. So the following expression is used to check the selected depth of a wall footing. V ultimate divide phi 0.75, I believe. Lambda is 1. F prime C will be given B web. I will talk about this one later. The next step, okay, the depth is good, everything is good. I need to figure out the steel reinforcement. Yes, the minimum is 4 inch, Oliver. Yes, the minimum is 4 inch. At the face of the wall, I will calculate the moment. This point is very important. Please pay attention. This point is very important. If you have a footing, strip footing, and we have a wall, like this. So we have two issues. We have issue with shear, and we have issue with moment. We need to solve this issue first. The issue for shear will give you a safe depth, D. Moment will give you the required area steel and then the number and the size of bars. Make sure you are understanding this point carefully. If you are talking about shear in footing, you have to measure a distance from the face of the wall, distance D, and draw a critical section. So this area multiplied by Q ultimate can give you V ultimate, which called ultimate shear. So if you are talking about shear, your critical section where a distance D from the wall face. That makes sense? But if you are talking about moment, it's a different story. Your critical section will be exactly at the face of the wall. So this area time Q ultimate can give you a force. This force at the mid distance. So this force time this little distance can give you the moment. As you know, any moment equal force time distance. That makes sense. So critical section for moment at the face of the wall. So if you multiply this area by Q ultimate, area time pressure will give you a force. Here is the force. And this force at this centroid of the area. So we have a distance here. If you multiply this force by this distance, you can get the moment value. Once you get a moment, I can get moment divide phi. Phi here is 0.9 BD square, and I can figure out the value of rho, and then I can figure out the value of area steel, and make sure you can check rho minimum and rho maximum for this steel reinforcement. So for strip footing, actually we have two issues. The first issue for shear, the second you have to choose a depth, make this shear safe. The second issue, steel reinforcement, we have to select area steel to make this moment safe. We have an example But before examples, do you have any question? Designing of footing is very, very, very systematic. But we have some concepts. We have some concepts. The first concept we learned today, where are the critical sections? It's very important. This point is very, very critical. Critical sections is different. Are you talking about shear? Yes. So the critical section where a distance d from the face of the footing of the wall here. If you are talking about moment, the critical section will be exactly at the face of the wall. This point is very, very important. Any question related to this point? Okay. I have a point before starting to solve this example. Guys, for designing strip footing, we have two cases. Sometimes you are talking about shear wall. What you mean by shear wall? We have a wall like this one. So this length is known around 20 feet, 10 feet, 5 feet. It's okay. So I can construct strip footing underneath this wall. So this length is known equal to this length of the wall. Sometimes I can increase from this side a little bit 1 feet and from the other side 1 feet or the same length. That's fine. That's fine. So I'm still confused. What is the value of this width? So if you get area required, this area will be length times B. So from calculation, I can figure out the area required. From the length of the wall, I can figure out this length. So I can finally determine the width of the footing. This is the first case. Second case, probably you are talking about a wall like this one. The length can be assumed infinity. It's very long. You are talking a very long fence around very huge area. So this length of the wall is extended from this side and this side. So what should I do? What do you think? If your wall is extended to infinity, I'm assuming it's infinity. Okay, that's fine. Your wall, your footing, I'm sorry. I'm gonna assume unit length 1 feet from the wall and 1 feet length from the footing. So area required equal unit length time B, which is this width. So make sure what's going on. Do you have a wall with a given length? So the given length will be the length of the footing. So I'm still looking for width. Sometimes the given wall is infinity. So you are talking about unit length. And what you are doing for this unit length will be the same for the next unit length, will be the same for the next, will be the same for the next, will be the same for the next, until you finish up the footing. For example, like this example, we have a wall footing to support 12-inch wide reinforced concrete wall with a dead load equal 20 kb per foot. Oops. So the problem did not give you what is the length. It gave you the thickness of the wall, but did not give you the length. Also, dead load equal 20 kb per foot for this wall, and the life load equal 15 kb per foot from this wall. So we have a wall, this thickness 12-inch. This wall is extended to infinity. I don't know when it will start or where, and where to finish or to end. I will draw a footing extended with the wall. I measured unit length 1 feet. This unit length has vertical dead load equal 20 kb. Vertical life load equal 15 kb. Because the units of these loads are 15 kb per foot. Dead load 20 kb per foot. So each 1 foot we have these values of load. So I'm gonna design only 1 foot from this footing. So what is the width of this footing? So I'm talking about this unit length, supporting this unit length of the footing. That makes sense? This point is clear for you? Okay, let's start. We have here some information are very important. The bottom of the footing is to be 4 feet below the final grade. Here is the ground surface. I will do excavation to construct this footing. Based on the information in the problem, this surface, the bottom surface of the footing is 4 feet from the ground surface. And gamma soil weight, gamma S, equal 100 pound per cubic feet. Few allowable are given or is given 4,000 pound per square feet. It's given 4 kb per square feet, so I converted it to pound. Anyway, if yield is given, if prime C is given, anyway. So guys, we have few steps. Let's start with the first step to design a footing. First step, what is the unfactored total load, which equal dead load plus life load without factors. Value of dead load 20, life load 15, equal 35 kb per foot. Second step, what is the ultimate total load? 1.2 dead load plus 1.6 life load. 1.2 times 20, 1.6 times 15. Your answer will be 48 kb barefoot. I'm gonna assume thickness. What do you think? Okay, keep walking. I will assume the total thickness equal 20 inch. So your depth will be 20 minus 4 will be 16 inch. I need to calculate Q net. Do you remember? Equal Q allowable minus gamma soil H soil minus gamma concrete H footing. Guys, I assumed this H footing equal 20 inch. 20 inch divide 12 is 1.67 feet. Do you know what is the depth of the soil above the footing? 4 minus 1.67. It will be 2.33. So H soil above the footing is 2.33. Gamma soil is given 100. Gamma concrete, I know gamma concrete 150, and the H for concrete is 1.67 feet. So Q ultimate is 4,000 minus gamma soil 2.33 times H times gamma 100. This H and this gamma. Gamma concrete 150, H footing is 1.67. So I can figure out the value of Q net. This one is 2. $3,516.5 pound per square foot. So guys, make sure Q allowable must be in pound per square feet, because gamma in pound per cubic feet. If you multiply it by HS in feet, your value here will be the same unit here. Gamma concrete is pound per cubic feet. H foundation must be in feet. So the final unit for this calculation will be pound per square feet. Guys, we need to figure out the area required. If you go back to your calculations, area required equal B divide Q net. P divide Q net. What is the value of P and factored total load? 35. Q net 3,516.5, but we have issue. This load in KIP, this load or this allowable Q net in pound per square feet. So I have to multiply this value by 1,000. The area required will be 9.95 feet square. Guys, this area required equal length of the footing time width of the footing. But for this footing, we are talking about unit length. So the length will be 1. The width is unknown. Area is 9.95. So what is the value of width? 9.95, approximately 10 feet. So the width of this footing will be 10 feet. And this footing will extend as the wall extending. Any questions so far? Looks good. Okay, I am done with area required, and I assumed the thickness to be able to calculate unit. We need to make a check. Do you think this depth, which is 16, which is coming from your assumption of the thickness, do you think this depth is good? So we need to check for shear. Yes.
Before we move on, can I ask something really quick?
Yeah.
The depth, the width we just calculated.
Huh?
So it's 10 feet for 1 foot unit length of the wall.
This width is a width for the whole wall, but we are talking about only unit length. So the width for this unit length will be the same like this unit length, will be the same like this unit length, will be the same like this unit length.
Right, but that's the wall. That's saying the wall is a 12-inch. So let's say if the wall was 24-inch, would you say B is 20
The same.
feet?
No. The B will be constant, 10 feet.
Okay, all right, thank you.
Okay. Yep. Okay, I will do it in more details one more time. We have a footing, we have a wall. This wall is supported by a footing. From calculation, we found this width of footing equal 10 feet. And we are talking about unit length. This length is 1 feet. The critical section for shear, anybody can remind me where is the critical section for shear? Do you remember where? Critical section of shear. By the way, the thickness of the wall is 12 inch, which is 1 feet. So guys, do you remember where is the critical section for shear? This information is very important. You have to keep it in your mind. Where is the critical section for shear at the remaining distance? Alex, your answer is correct. Oliver, I'm not sure the remaining. What you mean by remaining? Brian, your answer is correct. Oliver, I know probably you know the remaining means you have to measure here a distance D, which is 16 inch. So the remaining, or at this location first, we have critical section at distance D from the face of the footing. So the remaining area with Q ultimate can give you the ultimate shear force. So let me give you a question. Anybody can tell me what is the length here? What is the length of the remaining area? Can you figure it out? By the way, 16 feet, 16 inch will be 1.33 feet. So can you tell me what is the length here? I got answer. So can you give me your answer? No, no, Brock. One more time. I'm looking because most of the student and not student, everybody did this wrongly, unfortunately. What is the remaining distance here? Be careful. I know the total width is 10 feet. I know the thickness here is 1 feet. I know the distance I left here is depth 1.33 feet. Can you tell me what is the remaining distance? Probably I need to more time. No, 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 Alex, no, Borak, no, Brian. Thank you, Oliver. Yes. Thank you, Oliver. Yes, 3.17. First step, guys, I will draw my center line. So the remaining distance on this side from this center line will be 5 feet. From this 5 feet, subtract half feet and 1.33 feet, you can get the remaining distance. Does that make sense? This little distance will be 0.5, have 1 feet, and we have another distance here, 1.33. So all of these from 5 feet, I can figure out the remaining one will be 3.17 feet. That makes sense? That makes sense? Okay. So the only key, please go ahead and divide. Actually, I am giving you, I believe. No, I'm not giving you expression. Anyway, the first step, please go ahead and divide this width by 2. So B divide 2 minus wall thickness divide 2 minus D, you can get the remaining distance. Does that make sense? And make sure every distance in feet. We are talking about feet. This one in feet, this one in feet, this one in feet. So guys, I forget to mention something here. Q ultimate equal P ultimate divide area of footing. So P ultimate 48 times 1000 to be in pound. Area of footing will be unit length times this width 1 times 10. So Q ultimate will be 4,800 pound per square feet. So right now we have this area for shear. If you multiply this area by Q ultimate, I can get V ultimate. U ultimate time area for shear. U ultimate is 4,800. Area for shear, the length is 1. The remaining distance is 3.17. So this value of V ultimate equal 15,216 pound or 15.216 kip. Okay. We need to check. Do you think this V ultimate divide phi 2 lambda square root f prime c b web will give you a depth greater than what you assumed? Let's try. Depth equal V ultimate divide phi, cannot remember the expression, 2 lambda f prime c b web. Okay. So V ultimate is 15,216, must be inbound. Phi 0.75, 2 lambda is 1, because you are talking about normal weight concrete, not the concrete for Angel. It's a different concrete. We are talking about the normal concrete. Square root f prime c, the value of f prime c, 3,000. B web here means the length of the footing. You are talking about unit length, so this value will be 12. Unit length for the footing. Let's see what is the value of depth. So 0.75 times 2 times 3,000 under square root. .43 inch. Can you remind me what was the assumed depth? Wow, I assumed a depth equal 16 inch. And based on this assumption, I calculated the shear force at the critical section, and this shear force V ultimate give me a required depth equal 15.43, smaller than 16 that you assumed. You are good. Keep walking. The question is, if this depth value is 18, 19, 17, which is greater than what you assumed, I'm so sorry, please go back and assume what you got here. So please go back here one more time. I'm so sorry. So right now I have depth. So I can figure out the HF. So I can figure out Q net. So I can figure out the area required, because everything will be changed. Okay? And keep walking until you figured out a new depth. The new depth must be smaller than what you calculated before. Okay? Moment. We are almost done. But I need to remind you for something. Guys, we have a wall. This wall is supported by a footing. By the way, this footing has Q ultimate equal 4,800 pound per square feet. And you are talking about unit length. This length is 1 feet. And this width is 10 feet. Can you remind me where is the critical section for a moment? Do you remember? Where? Do you remember where is the critical section for a moment? At the wall face. Yes, Oliver, yes. You have your assumed depth must be greater than the calculated one to make sure you are safe. So at this face, we have a critical section for a moment. My question is, anybody can tell me what is the length here? What is the length for this area? Do you know how much? This one, it should be more simple, more easy. 4.5, that makes sense. Thank you, guys. 4.5. So we will have a force at the centroid here. This force will equal Q ultimate time area for moment. Okay, Q ultimate 4,800. This area is unit length 1 times the remaining distance, as you said, 4.5. So this force will be 21,600 pounds. I'm looking for moment. Okay, this force at a distance from the face of the wall equal 4.5 divide 2. That makes sense at the mid distance. So this force at distance from here 4.5 divide 2, and from here 4.5 divide 2. So if you multiply this force by 4.5 divide 2, your moment will be 48,600 pound foot. I am done. M ultimate divide phi B D square. M ultimate for 48,600, but must be multiplied by 12 because this value must be pound inch. Do you remember? Phi 0.9. B unit length of the footing. So unit length is 1 feet, which equivalent to 12 inch. Depth, we assumed a depth equal 16, and this is okay. So 16 square. This value will be 210.93. Remember, F prime C equal 3,000. F yield equal 60,000. So I can go to a table to figure out the value of rho. Let's do it. Just a second. Table. Uh, 3,000, 50,000, 50,000, 60,000, 3,000. Yeah, here you go. The value is 210. Do you have 210 here? I believe yes. Actually, we have 212. That's fine. To your value of rho 0.0037. So value of 0.0037. I need to check something. Do you remember? I need to check something. for grade 60, F prime C 3000, rho minimum 0.0033, rho minimum 0.0033, rho maximum. Do you remember what is the rho maximum? 0.0155. I believe your rho from the table greater than rho minimum and smaller than rho maximum, you are good. So your rho, which equal area steel divide B times depth, equal 0.0037. Keep walking. Area steel divide B unit length. Unit length of the footing, which is 1 feet, equivalent to 12 inch. Depth 16, equal 0.0037. So I can figure out the value of area steel. .7104 inch square. If you choose number 4, your number here will be 4 bars. Number 4 for each feet of this footing. Guys, remember all of these calculations. All of these calculations for what? Unit feet of the wall. So your final answer for area steel will be for each foot or feet from the footing. So this footing, and here is the wall. This steel reinforcement will be in this direction. How many? 4 bars, number 4 every 1 feet. So if you have a length here 1 feet, you should have 4 bars. The next to 4 feet, the next to 1 feet, you should have another 4 bars. So this is the mean reinforcement. One of you will ask me, this is the only reinforcement? No, we have another reinforcement in the longitudinal direction, which is minimum reinforcement. We have only one way. This footing looks like one-way slab. We have one way, mean steel reinforcement, and the second way, which is the longitudinal direction, will be minimum reinforcement. So just steps, and I hope if you are lucky to assume a good depth, and this step will be okay, and you don't need to go back to assume a new depth. In the exam, if this depth is unsafe, if you did this calculation and your depth is unsafe, okay, go ahead and say we should assume a new depth, but keep going and finish up your calculation based on your assumption. You don't need to repeat this calculation one more time.